Hi, welcome back. Today we have a question. When the velocity of a flow in an open rectangular channel of width W is relatively large, it is possible for the flow to jump from the depth y1 to depth y2 over a relatively short distance, as shown in figure here. This is referred to hydraulic jump. Express y2 in terms of y1 and v1. Assume a horizontal uniform flow. Right? So the question asks, express y2 in terms of y1 and v1. The first step number 1 that we need to use is we need to apply the momentum equation. Right? So in order to get this expression, we need to apply the momentum equation. So in this direction, we only focus of x-axis. So summation, apply momentum equation, definitely summation of force in x component is equal to mass, flow rate, velocity 2x minus velocity 1x. So from here, this is considered as equation 1. So we need to find v2x minus v1x. And then step number 2, we need to apply the continuity equation in order to get the velocity. Apply continuity equation which is Q equal to AV. So Q1, since Q1 equal to Q2, definitely we can replace Q with A1, V1 equal to A2, V2. So, area 1, right? In order to get the area, we have to look at here. So, imagine that we have our eyes here. So the area would be like this. This is our cross-sectional area. It would be like this. It would be like this and like this. Alright, this is y, and this is width. Remember, given width is w. Also the same here. When we look at here, this is y2, this is width. So area is width times y2. So area 1, so we need to rearrange this one. V1 become the subject equal to area 2 over area 1 multiplied with velocity 2. So area 2, by using the previous equation, previous formula, area 2 is equal to y2 multiplied with width over y1 multiplied with width multiplied with velocity 1. So width with width we can cancel out. We leave only v1 equal to y2 over y1 v1. Right? So this can be equation 2. Step number 3 is that is we need to we know that alright, so step number 3 is we look at here, we have the force here. We have force 1 and force 2. So from force 1, we will get the formula of force equal to pressure times area. So force 1 definitely pressure 1 A1, and force 2 is actually equal to P2 A2. Remember that this force directly related to the hydrostatic force. So we use the formula of hydrostatic force. F equal to pressure equal to rho GHA. So this force acting at the middle. So this is half. This is half. So we should place this as the half. Alright. And then this is become the equation of 3. Using step number 4, substitute equation 3 and equation 2 into equation of 1. Alright. The equation of 1 is this. So from here, the f of x, we can say that f of x is F1. So this F1, this is positive, and minus F2 equal to M V2x minus V1x. So F1 is positive. So F1 equal to 1 over 2 rho G H A1 H1 A1, right? And minus 1 over 2 rho G H2 A2 equal to, and the mass flow rate here, m dot refer to rho AV V2x minus V1x. So from here we need to expand further. H1, H2. So this H refer to Y1, H2 refer to Y2. And then we need to replace H1 with Y1 and H2 with Y2. Area we need to replace as well, right? If we use the area of 1 at point 1, we should make it consistent. Area, alright, if we use the area 1, use the velocity 1. So y multiply with width. Let's say we use at point 1. This is 1, this is 1. Alright, the width is constant, shall not change. So 1 over 2. Alright, 1 over 2. Rho G we replace with gamma. Y1, A we replace with Y1W. Right? Minus 1 over 2 gamma. This we replace with gamma. Y2. This area we expand further, Y2 W equal to rho, this is rho constant, the same thing, A we replace with Y1 W1, velocity, alright, this is velocity, and then let's say this is area 1, definitely this is velocity 1. Okay, so V2x minus V1x. So previously we found that V2x is actually V2. This is only the x-axis. So this is actually right. This is actually V2. So V1 have the relationship with V2. So this is doesn't. So this V2x we replace with Alright, so the v2x we can replace with this one, right? We can say that v2 equal to y1 over y2 multiply with v1. Alright, this term we replace into this part. Alright, so we replace this one, v1 definitely will get here v2 refer to y1 over y2 v1 minus with v1. Okay, so after this we need to simplify further the equation, and then we will get here 1 over 2 gamma y1 squared w minus 1 over 2 gamma y2 squared w equal to, and this one we try to simplify further. Alright, we'll get the rho y1 w. Okay, y1 v1 minus y2 v1 over y2. So this one we can look at this velocity one, the same term we can move outward, move out. This width we can cancel out, only left 1 over 2 gamma y1 squared minus 1 over 2 gamma y2 squared equal to rho y1 v1. This v, alright, basically this v we have remember that we have the v component here, so this one shall be multiplied with v as well. So v, there is a v here, v multiplied with v, we get the v squared. Alright, so bracket here only left y1 minus y2 over y2. So from this term we can simplify further. Alright, we can simplify further. This y1 and y2, these have the same term, we can factorize 1 over 2 gamma, only left y1 squared minus y2 squared equal to this rho y, okay, rho y1 v1 squared y1 minus y2 over y2. From here, we can actually expand further based on our mathematical understanding. This y1 squared minus y2 squared, we can use the methods of factorization. Remember, a squared minus b squared, we can expand further, become a minus b, a plus b. So we try to correlate this with this 1 over 2 gamma y1 become y1 minus y2 bracket y1 plus y2 equal to rho y1 v1 squared y1 minus y2 over y2. So you can see the left having the same term, this With this, we can cancel out. Alright, only leaving this term 1 over 2 gamma y1 plus y2 equal to rho y1 v1 squared over 1 over y2. Okay, so from here we can actually divide the whole term here with the density. So from here we try to divide to simplify further all this term with density. Right, try to divide all this with density, because this gamma is actually we expand become rho g. So we divide all this with density, only left density with density cancel, density with density cancel, only left, right, g over 2 y1 plus y2 equal to y1, this one move to other side, over y2 v1 squared. So from here, rearrange, right? From here, you need to expand further to multiply inside. So gy1 over 2 plus gy2 over 2 equal to equal to y1 over y2 v1 squared. So you try to move y2 to the other side, multiply, so gy1 y2 over 2 plus gy2 squared over 2 equal to, alright, y1 v1 squared. So you try to make the y2 become the variable. Okay, this one you try to move this one 2 and 2 to other side, you become, okay, gy1 y2 plus gy2 squared, this one you equal to 2y1 v1 squared. You try to rearrange this equation, make it become the quadratic, because we have the quadratic. You rearrange become a standard quadratic equation, ax squared plus bx plus c equal to 0. Try to rearrange into this equation. Let the y2 become the variable here. So this one become the first term, gy2 squared plus, okay, gy1 y2, and then you move to the other side, become minus 2 y1 v1 squared equal to 0. So from here you can see that A, you compare with the standard quadratic equation, A is actually equal to g, B is actually equal to gy1, and C is actually equal to the whole term, negative 2y1 v1 squared. So by using the quadratic formula, which is x equal to negative b plus minus the square root of b squared minus 4ac over 2a substitute all the value into this formula. So x will refer to the y2. Because remember that the question asks express y2. So here is how we lead to expressing the y2. Y2, the x here is actually, you can see here, we compare x with y2. X with y2. Okay, you can see here the same. Right, the same here. So that's why we change x with y2. Negative b, which is negative gy1 plus minus square root of b, which is bracket gy1 squared minus 4a is g, c is the whole this negative 2y1 v1 squared over with 2a, which is 2g. Thus, you simplify the equation further, definitely you will get the final answer is, right, you try to simplify gravity, velocity 1. Okay. Alright, then you need to simplify further. Negative gy1 plus minus, inside here you need to expand g squared y1 squared, negative with negative, positive, 4 multiplied with 2, 8 g, right, y1 v1 squared over with 2g. So from here you can simplify gravity with gravity, and you will leave negative y1 over 2 plus minus, right? This one you try to simplify further. Okay, g. Okay, you factorize g squared y 1 squared plus, okay, plus 8y 1 v1 squared over g. Because we factorize g squared, we divide with g squared, so only left g over 2g. And finally you get negative, this one is basically, okay, y1 over 2 plus minus, this factorize square root of g, you will get g square root of y squared 1 plus 8y1 v1 squared over g over 2g. So gravity with gravity cancel out, and 2 and 2 we have here, leave it only. We factorize 1 over 2. The final answer is negative y1 plus minus the square root of y1 squared plus 8y1 v1 squared over g. That is the final answer.